welcome to class. Today we shall be dealing with motion along an inclined plane. Let's say this is a plane inclined at an angle alpha, okay, to the horizontal. So this is a body resting on the plane. There are 5 forces acting on this body. The first one is the force due to gravity. The force due to gravity, that one is mg. We call it the weight of that body. And then there is another force acting perpendicular to the what? To the plane. Perpendicular to the plane, that is, it makes 90 degrees with the plane. And so that force is mg cos alpha. That force is mg cos alpha. And then there's a normal reaction, that is the force exerted by the plane on the body to keep the body on that plane. So and that force is a normal reaction. We call this reaction. Okay, so there is another force along this plane, parallel to the plane. Let me put F. Okay, that force is the one that tends to make the body not to slide down. It prevents the body not to slide down. It prevents the body from sliding down the plane. Okay, it's holding the body so that it won't slide down the plane. And there's another force tending to make the body slide down the plane, and that force is mg sine alpha. Okay, mg sine alpha. So this is the force that is tending to make the body slide down the plane. Okay, now if F is greater than mg sine theta, for instance, if F is greater than mg sine theta, that means that this force will be pulling the body up. Are you getting that now? So that means that net force will be equals to F minus mg sine alpha minus mg sine alpha. So F minus mg sine alpha will be equals to ma, where a is the what? Acceleration of the body. Okay, so if F now is less than mg sine alpha, that means that what? Our net force, which is mg sine alpha now, minus F, will now be equals to ma. Okay, there are situations, okay, if the body is now at equilibrium, that is, it is neither going up or down, that means the body is not in motion. So if the body is not in motion, that means our net force, which is F minus mg sine alpha, will be equals to 0, because the body is not in motion at equilibrium. Okay, so that will be at equilibrium. Let me write it at equilibrium. At equilibrium, that means F minus mg sine alpha equals to 0. So F equals to what? Mg sine alpha. Okay, now at equilibrium also, because the body, the inclined plane is holding the body, and the weight, the same force is acting the same force. Okay, the reaction is equal to what? The weight. I get that at equilibrium the reaction is equal to the what? The weight. So because the body, the plane is holding the body in such a way that the body, the plane is not breaking. Okay, so that means that the reaction is equal to the what? The weight. That is explained by the Newton's third law, which says that to every action there is an equal and opposite reaction. So what I mean here is that our R, which is normal reaction, is also equals to what? mg cos alpha. So what I want to show is the relationship between the force and the normal reaction. Okay, so if we divide, let's say this one is equation 1 and equation 2, dividing 1 by 2, we are going to have F over R equals to mg sine alpha over what? Mg cos alpha. So from there we have f over r to be equals to sine alpha over cos alpha. So f over r will be equals to tan alpha. So therefore our f equals to r tan alpha. So in the next video we are going to solve some problems based on motion along an inclined plane. Thank you. God bless you.